Okay, so now we're talking about the equilibrium of parallel force systems, and we have the same equilibrium equations. The sum of the forces is equal to 0. So the sum of the forces X is equal to 0, the sum of the forces Y is equal to 0, and the sum of the moments is equal to 0. And we need to find the reaction forces at connections. So to the system, we're not going to be able to just use the force equations like we have at the single point problems and the concurrent forces problems. So we're going to have to write a moment equation at some point. Alright, so this is a little different. You see that the system looks a little different now, okay? And we have reaction forces at the pin and the roller, and we need to calculate those. So let's go ahead and draw them in. Okay, at a pin, there's going to be a reaction force in the Y and in the X, and at a roller you only have a Y reaction force. Alright, so let's label these. This is RAY. This one's going to be RAX. And this one will be RBY. Okay, so let's start by doing the sum of the forces X. That's equal to 0. And we only have the one X force here, okay, because there's nothing at an angle, there are no external forces that are horizontal, so we end up with RAX is equal to 0. Right? But now let's do the sum of forces Y. It's equal to 0. Alright, and as we move down, we have RAY is drawn in a positive direction. Whoops, clicked somehow with my arm there. And get back. There we are. Okay, so RAY is positive, and then we have minus the 500-pound force, minus the 2,000-pound force, minus the 800-pound force, minus the 1,500-pound force, plus RBY. So that's the sum of the forces in the Y direction. Alright, now the problem is we have one equation and two unknowns. So we need another equation. Alright, so that's where we're going to write the sum of the moments around A. Okay, remember that we're going to consider that counterclockwise is a positive moment. Alright, so let's start here. RAX and RAY are applied at the point, so they don't cause a moment. The next one is the 500-pound force. Remember, if we stuck a pin in A here and pushed down here, it would cause a rotation. That rotation would tend to be this way. Alright, so that is considered a negative moment. So we'll use negative. Alright, and that's because the moment's negative, no other reason. 500 pounds times 2 feet. Okay, the 2,000 pounds is also going to cause a negative moment, so we'll do negative. Okay, 2,000 pounds times, this is 2 plus 3, 5 feet. So 800 pounds also going to cause a negative moment. We're pinned at A, we're pushing down here, that's going to be counterclockwise. So that'll be a negative sign again. 800 pounds times, okay, now we've got 2 plus 3 plus 4, 9 feet. Again, 1,500 pounds will cause a negative moment, a clockwise rotation. So 1,500 pounds times 2, 3, 4, that's 9 plus 2, 11 feet. Okay, then the last one is RBY. It's pushing up. We're pinned at A, so that's going to tend to be counterclockwise, which is positive. So we'll use plus RBY times the total length. Okay, so that is your sum of the moments around A. So now if we do some combining of terms, we can solve for RBY in this equation. Alright, so let's do a little punching in our calculator. Okay, and I get 28,309 pound-feet. That was negative. Plus RBY times 12 feet. Okay, so if I move the 28,309 to the other side, divide by 12. Get that RBY is 2,359. Okay, I appear to have made some data entry errors because all these terms are correct, but my number was wrong here. So this number is actually negative 34,700. I hope you're punching into your calculator and caught that. Okay, 34,700. So when I divide that number by 12, I get 2,892 for RBY. Alright. So now I can take this number, plug it back into sum of forces y. Alright, so I have RAY minus, let's combine all those, 2,500, 800, 1,500, minus, 4,800 pounds plus 2 equals 0. Alright. Okay, so I get RAY minus 1908 pounds is equal to 0, and RAY is equal to 1,908 pounds. Positive. Okay, so these are our answers. RAX is equal to 0, RBY is equal to 2,892, and RAY is equal to 1908. Hope this helps.